We're on our next ToDoodle about division. The warm-up could be done with multiplying or could be done with division. Either way, it was an exciting bus trip. But now we're really going into how division works. And if I turn the page, it will look like long division, except we're not there yet. We're going to just talk about somebody who is a casino dealer with a superpower. And their superpower is that if they have a stack of cards, and we want to have 128 cards. So here's 100 cards, and here's 10, and I'll duplicate that. So there's 20 cards all piled up on top of each other. I'm going to put that on the back. And then we want 8 single cards. 1, 2, 3, 4, 5, 6, 7, 8. Their superpower is that they can reach into the stack of cards, and if they want, pull out 1 or 10 or 100. So imagine they have good fingertips and can just feel, this is 10 cards, and hand it to Kiana. Or they could reach deeper in the stack and say, this is exactly 100 cards, and hand it to Christian. Make sense? By the way, I'll put this in chat. If you don't know who Richard Turner is, you should look that up. He went on Penn and Teller's Fool Us, if you know that show. He is the most famous card mechanic alive today. He actually does have fingertips where he could pull off 10 or 100 cards if he wanted. So we're going to try and deal out cards to 4 people sitting at a table. So our person first says, well, I can grab 100 cards at a time, so I will just do that. But I don't get to go all the way around the table when that happens. I don't have 400 cards to give everyone a stack of 100. So that's not actually going to help me yet. Is everyone okay thinking about that? So then the person's going to say, I can take 10 at a time with my fingertips, and I can go around once, 10, 20, and I have lots of 10s here. So I'm going to take this stack of 10 and turn it into 10 10s. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, if I count right. 1, 2, 3, 4, 5, 6, 7, yeah. So goodbye 100, we don't have this 100 anymore. And I'm going to keep dealing out cards, 10 to you, 10 to you. Can I go around the table again with 10s? Sure. 10 to you, 10 to you, 10 to you, 10 to you. Can I go around the table again with 10s? Sure. Yeah. 10 to you, 10 to you, 10 to you. Okay, now I'm out of 10s. Now we have to go one by one. So you get one, you get one, you get one, you get one. Everyone gets another single, and then we're out of cards. We're not dealing out cards anymore. Does that story we just told about dealing out cards make sense? Okay. So we're going to do the same thing now with long division. There's another method, but it's not going to fit on this page. So long division says, how many times does 4 go into 972? Can I deal out 100 cards at a time with, I'm sorry, I have 972 cards in my deck. That's what goes into means. I want to deal them out among 4 people. So if I have more than 900, can I give 100 to everybody? I could, right? And I could write 100 there. Can I go around again? Yeah. Now I wrote 100. That's actually not right. What should I write instead of 100 for the first time I go around the table?
2. Like just a 2 because 4 goes to a 9 twice.
It will be a 2. There will be a 2 happening. But that's
I was saying 3.
If I have my square table and I go all the way around 100, 100, 100, 100, how many cards have I just put on the table?
400.
400. And that was one trip around the table. Can I go a second trip around the table?
Yeah.
Yeah, so now I'm up to 2 trips around the table. And not 400, but 800 cards are on the table. Everyone with me okay?
Yes.
So 4 times 2 is 8. 9 minus 8 is 1. There's 100 cards still in my hand. And there's also the 72 that were there to start with. So I'm going to pause right now, and except for the fact that maybe the way you're used to it, you wouldn't have written all of this yet. Right? There's maybe all you wrote is like, it doesn't really cover it that much yet or something.
I'm confused because usually I was taught like how many times does the 4 go into the 9 twice, and how about 4 goes into 97 or whatever, you know, like start.
Yep.
But I don't. I'm confused.
This part should look the same. 4
Okay.
times 2 is 8. 9 minus 8 is 1. Bring down the 7.
Oh, okay, so yeah. Okay, yeah, okay, never mind.
So now at this point in the story, we have 172 cards in our hand. We can't go around again with hundreds because that takes 400 and we don't have 400. So we're going around with tens. If I go around once, how many cards have I put on the table? 10 at a time.
40.
40. But I don't need to stop with just once. How many times can I go around before I can't do it anymore? Our times tables for 4 is here.
22 or something.
Yeah, 40, 80, 120, 160, but then 200 is going to be too big. So 160 is what I can do. So I can go around 4 times. And that's 160 cards that are now on the table. Now I have 12 cards left in my hand. I'm going to deal them out one at a time to the people around the table. How many times will I go around?
3 times.
3. Mhm. And we're done. Let me repeat the story. We had 972 cards. So I'm going to take this 100, 1, 2, 3, 4, 5, 6, 7, 8, 9. Take the 7, the 10, 1, 2, 3, 4, 5, 6, 7, and 2 cards. Everyone okay that we have 972? And I'm dealing them out. So first I say, here's my table. Everyone gets 100, because I have the superpower where I could pick 100 cards off the top of the deck accurately. And I can even go around a second time. So I've gone around twice, and that used up 800 cards. What's left? 172 cards. With me so far? Now I can't go around the table again with hundreds. I only have 100 and some, and that takes 400 to go all the way around. So let's start dealing 10 at a time. So here we go. I can go around 10 at a time. 1. If I'm going to go around 10 at a time more, then I need more 10s. So I'm going to take this 10, this 100, and make change, turn it into 10 10s. So go away, make 10 10s. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So now I can say, let's go around another time, 10 at a 10 at a time. And another time, 10 at a time. And another time, 10 at a time. And I miscounted once somewhere. Okay. So that was 4 times around. 4 times 4 is 16. So I used up 160 cards on the table now. What's left? A stack of 10 and 2 more. So 12 cards are left. I want to go all the way around 1 at a time, 1's column. How many times can I do that? Well, if I started, I'm going to run out of 1's. So I need to take this 10 and make change. So goodbye 10. Let's get 10 1's for it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then I can say we're going to go around the table once. We're going to go around the table a second time. We're going to go around the table a third time. And now I'm out of cards, so I'll stop. So 3 times around the table with 4 people used up the last 12 cards. There's none left in my stack. If I was to count any one of these stacks, it would be 243 because they each had their turn. Let's actually check. Is that 243? Drum roll, please. There's 10, 10, 10, another 1. Ta-da, it worked.
So 243 can go into 972 12 times?
4 times.
4 times. Gotcha.
Or the other way, 4 goes into 972 243 times. Either order makes sense to say. So long division is weird because division is about making piles that are the same size. If I said that there's 4 students in the class, I have a dozen eggs, let's divide the eggs, you would each get 3 eggs, and that would be making a lot of sense. Okay, division is about making piles that are the same size. So why does repeatedly multiplying and subtracting make piles of the same size? It would be very rare if you've ever had a math teacher that tried to explain this to you. It's not your fault. It is just that the math teachers in most schools don't know this. So think about the dealing out cards. And this is why multiplying and subtracting makes piles of the same size, because you're dealing out cards when you're dividing.
This we consider like an algebra problem.
There's no algebra, because algebra is about expressions, which we'll talk about.
Okay.
This is just arithmetic.
Got you. That makes sense now.
Okay, for now, let's keep going. The problem with long division is I have to know that 8 is the right number to put there. So there's a method that your kids may have been taught in school more recently called the line method. And it's exactly the same, but you don't need to know your times tables. So I'm going to say I have 100 cards at a time. I have 972. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 20, 30, 40, 50, 60, 70, 2 cards. Okay. And I want to deal them out to the table. But I don't have to know that 4 times 2 is 8. I could, but I don't have to. Okay, so we're going to start by saying, let's give everyone 100 cards. Actually, I'm going to start by moving this down. There. Okay. I'm going to start by giving everyone 100 cards. So here we go. Everyone gets 100 cards. And I'm going to start by giving them another 100 cards. So ta-da, everyone gets another 100 cards. Everyone with me so far? I can't go around 100 times with the piles of 100 again. That would take 400, which I don't have. This is what I have. Do I have to know how much I have, like I do for long division? No, I mean, it is 172, but I don't have to know that. Okay, so let's start going 10 at a time. So let's give everyone 10 cards. Can we do that again? Sure, but I need to make change with this. So that goes away. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, now we can go around 10 again. This is kind of slow. Why don't I go around giving everyone 20? So you get 2 10s. And this person gets 2 10s. And this person gets 2 10s. And this person gets 2 10s. So you can use your times tables and multiply. You don't have to always do 1 times 10 or 100. You can do times 2, that's fine. But you don't have to. Okay, now I have 12 cards left. Do I actually need to know what's 12? No, I don't have to write the 12 anywhere. I mean, it is 12, but I don't have to realize that. I want to give everyone 1 card at a time, because I can't go around again with 10. That would take 40, and I just have to see it's less than 40. So let's go around. Oh, I have 10 cards here. That seems like a lot. Let's make change. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So let's go around twice with 1 card each. So 2 cards for you, 2 cards for you, 2 cards for you, 2 cards for you. And let's go around once more with 1 card each. 1 for you, 1 for you, 1 for you, 1 for you. And then I'm done. This is how many cards each person got. Everyone okay with that list? So then we add them all up. And what do we get? In the ones column, 2 and 1 is 3. In the tens column, 1, 2, 3, 4. And in the ones column, just 1 and 1 is 2. So we get the same answer as before, unsurprisingly. It's just that instead of 800, we broke it up into, instead of 200, knowing that 200 is the right thing to do, we broke it up into 2 100s. And instead of 40, knowing that 40 is the right thing to do, we did a 10, a 10, and a 20.
That way
And-
was easier.
And instead of 3, knowing it's the right thing to do, we did a 2 and a 1, right? So you can kind of break things up if that helps you.
Yeah, that was easy.
You like this one better?
Mhm.
So if you were taught this in school today, you don't have a slider like I do. So you would just kind of write it this way rather than actively like I did. But for people that are used to writing this part on top, that's why I sort of did this sliding down. Does that make sense? So that's the line method. If you like that, ta-da, that works great. Questions about that?
I've actually never heard of the line method, and I am so bamboozled by what you did.
That's okay. Again, I don't think in the GED, anyone's going to say do 972 divided by 4 by hand. Maybe I'm wrong. I'll be able to let you know soon. But if you understand long division, then maybe you'll feel smart. And if you don't understand why a long division actually does division, then maybe this helps you. So Okay, the third method for division is the box or rectangle, even though it has nothing to do with the box method for multiplication from the last ToDoodle. And it's just keeping track of things with place value in a box. It's not a new method. So I can say I want to do 4 goes into 900 first. How many times is that? That's 2. So 4 times 2 is 800. Let's do our subtraction. 972 minus 800 is 172. So then I have 172 left. How many times does 4 go into 172? It would be 40 something. So 4 times 4 is 16 with a 0. So 160. Now I'm at 12 for the tens column. And how many times does 4 go into 12 with ones? That would be 3. 4 times 3 is 12, and we're done. So it is taking the parts of long division, and instead of writing them on top of each other, writing them sideways. For a very few people, they like this. But most people say, no, if I want to write all of this, I want it lined up nice by place value the whole time. This is better. So just like for multiplication, the Lewis Carroll method is like, no one ever uses that. And this one, I'm only showing you because maybe your kids were taught this and you were wondering what's happening. Okay, ready for you to try? Okay, so 12 goes into 4,980. Do this however you want. You don't have to do anything that is what I have done today. And I'm going to stop the recording. We'll talk about it as we go, and maybe it will make more sense with the vocabulary we've now established of dealing out cards. We just did this page together. We wrote everything out with zeros since we multiplied by 4, not just a 4, but 400. Then this wasn't just 48, but 4,800, 4,800. Similarly, this wasn't 1 times 12, it was 10 times 12, so 120. Maybe you like how it's written. Other people say, no, that's not how I was taught. I just want to have little arrows, and we're going to bring down the 8 and bring down the 0. That's fine. There's nothing wrong with writing it this way. The zeros are still here, you're just not writing them. So they both work, be happy. Okay, on this page, we did it with the line method, where let's take away 200 times 12. So that would be 2,400. 2 times 12 is 24 with 2 zeros after it from the 100. And then after we subtracted, let's take away 200 again. Now we're down to tens. 1 times 12 is 12 with a 0 after it. We got down to 51. I'm sorry, 60. Then we had to do some carrying. We tried taking away, because we didn't realize that 60 would work with a 5. We first did 36 and then we did 24, and it all works out the same. I'm not going to go into all the details on the video because most people don't want to learn this way. It's just to help if your kids were doing this in school and were saying, Mommy, Daddy, help me with this. Okay, and this one I think I'm going to skip because it's just going to be the same as long division, except each of these little pieces we do in a box, and there's not really any advantage to that. Okay, so now it's your turn. I've been doing all the writing because I have a pen and you don't, but you can finally do this like a jigsaw puzzle. We have 3 long division problems. 1, 2, 3, and all of these other things, you can like slide them together and try and make something out of them. Does that make sense? So try and assemble the jigsaw puzzles under and above the division problems correctly. And I'll pause the recording.